we got a quick one to start us off here, guys. So we're jumping ahead to 6.5, and this section should really take us maybe 10 minutes, not even. And then we're going to jump back. We have 6.3 and 6.4 left after that. Okay, we're wrapping up Calc class. We are right about there. And then we have to prep for the final, and then that's pretty much going to be it for us. So let's power through these final 2 weeks that we have left in front of us here. So for 6.5, this is the average value of a function. And you learned how to find the average of something way back in, I don't know, 5th grade or so. And we call that x bar. And you add together a whole bunch of things, n of them, and divide by n, and you find your average. Like for your 4 marking periods, you'd add all 4 together, divide by 4, and that's your overall average for a course. It's pretty much going to be the same thing here in calculus. So the average value of a function, f, is f average. That's not fav. F, and it's like a subbar, av. So that's going to be, we sum up a bunch of things. That's what an integral is of this function from a to b. But then you have to divide by how big that integral is. So we find that by dividing by b minus a. Nice simple formula to find the average of something. Hopefully it makes a lot of sense, right? You're adding up a bunch of things here with the integral, and then you're dividing by how big that integral is. Let's do an example. Let's find the average value of the function 1 plus x squared on the interval -1 to 2. Okay, how we're going to set this up is we need the b minus a, 2 minus -1, our integral -1 to 2 of 1 plus x squared dx. Pretty straightforward setup. This opening little bit of algebra here is going to bring us to 1/3. Got to do some calculus here. This is going to bring us to x plus 1/3 x to the third from -1 to 2. Right, and we're in here for that parentheses. Okay, let's plug in and start seeing what we're getting here. So we're going to have 1/3, 2 plus, this is 8/3 minus, and this is going to be a -1 and a minus 1/3 all around here. Okay, let's combine things. These double negatives are going to distribute. That makes it 2 plus 1. So we really have a 3 here. And here it's 8 minus a 1 because they both have the thirds there. It's plus 9/3. Really 3 plus 3 is 6. And we have that this answer is just 2. So the average value of this function is going to be 2. Before we move on, let's talk about what that even means. So if we drew a graph of this thing, it would look something like this, -1 to 2. And think the integral is forcing us to add up all of this area, which we found out was 6 here. But then we're dividing it and seeing what that comes to. How I think of this in my brain is, let's say we took this and smushed it all down and tried to make it into one compact rectangle. We would know that the height of the rectangle would end up being right here at 2. So that little bit here could be smushed in here, right? So all of this just becomes kind of in your brain. You can think of it like this, -1 to 2. And that's the average, right? We kind of take a lever, press down until all of a sudden we have this nice little rectangle here. And the height of that rectangle is the average value. It's how kind of tall what the y value is. That is pretty much it for average value of a function. There's one extension that we can make off of it, and it's kind of incorporating the mean value theorem back from a couple chapters ago, but for integrals. Remember, the big thing for the mean value theorem is if you have a continuous function on an interval, there's some number c in that interval such that there is an f of c that equals the average. So there is an exact point that will be equal to the average is all that is saying. Let me say that once more. The mean value theorem for integrals states that if it's continuous, there's going to be at least one value on that function that's equal to the average value of the function overall. Let's apply that for the function we just looked at, this x squared plus 1, and we figured out the average already. Yeah, and that's the same formula as before, sorry. The big takeaway is that we need to find some c that equals the average. We found out that the average already was 2 from the last question. So we know 2 has to equal some f of c. You may be saying, well, what's f of c? Put c into the function that we actually have for us here. So this is going to be c squared plus 1 has to equal 2. Doing some big brain math here. C equals plus or minus 1. And some of you may be saying, ooh, from before you have to throw out things that aren't in the interval. Not the case for the integrals. We can actually include the endpoints. So our answers here are both plus 1 and minus 1. We have two separate answers here. Really, all that is saying is if you put 1 into the function, it equals 2. Yay. We put negative 1 into the function. Guess what that's going to equal? Also 2. Those are all the values in this range that will equal 2, which, if you remember from 2 minutes ago, that was our average that we had obtained. That's really it for this section. Real quick, real easy. Homework should be fast off of this. I'm going to post a video for 6.3 this week, 6.4 next week, and then we're going to start talking final preparation for the course. Okay, take it easy, guys.